VLSos here. This is a video lesson on optimization, a very practical use of calculus. I'm going to read a contextual problem. Afterwards, we're going to think about the situation, and then we'll read it again more carefully and take out the information that we need from the problem in order to answer the question. A store has been selling skateboards at the price of $40 per board, and at this price, skaters have been buying 50 boards a month. The owner of the store wishes to raise the price and estimates that for each $1 increase in price, 3 fewer boards will be sold each month. If each board costs the store $25, at what price should the store sell the boards in order to maximize profit? This is an optimization problem because we're looking for the maximum in the situation, maximum money made. We call that profit. It's best to slow down when challenged with such a problem and understand the context of what is being described in the problem before attempting to do the math. This is a business. It costs the business some money to produce the product, a skateboard. The skateboard has a sales price, which they can choose. People who buy skateboards are not willing to pay too high of a price. So the profit is not going to be made by simply making the skateboards very, very expensive. Similarly, if the skateboards are too inexpensive, then the profit will not be much because it costs money to make the skateboards. If we lower the price a whole lot, there might be many more skaters that are willing to buy boards, but the profit made on each board will not amount to much. So with that in mind, let's see if we can label some variables and find some equations that relate those variables to help us then find an answer with calculus. A store has been selling skateboards at the price of $40. Immediately, we know that the price of a skateboard is important to this problem. So I'm going to choose P to be price. At this price, skaters have been buying 50 boards a month. Well, the number of boards bought is important. So I'm going to assign the variable N to be the number bought. This is a variable because the number of boards bought will be dependent on price. And it's worth noting that the $40 per board and the 50 boards sales per month are numbers that I haven't made sense of yet. Continuing in the reading, the owner of the store wishes to raise the price and estimates that for each $1 increase in price, hold it there, I have this concept of adjusting the price by increases. So the number of times that I increase, I'm going to assign a variable. I will be $1 increases in price. And now I can backtrack and think, if I'm going to increase a price, it must be increasing from some amount. And that amount was given to me earlier in the reading. $40 was the starting price of each board. So I can think of price now as an expression of the $40 plus the number of times I'm going to increase it by $1. I'm now relating the variable P and I. I'm going to continue reading. The store wishes to raise the price and estimates that for each $1 increase in price, 3 fewer boards will be sold each month. So the number of boards is going to be reduced depending on increases in price. And the number of boards I knew from earlier to be 50 if I don't increase the price at all. So I can relate N, the number bought, with the expression that there will be 50 boards but I will subtract 3 for every increase of $1 in price. I'm getting mathematical expressions that relate my variables. This is a good thing. Continuing, if each board cost the store $25, at what price should the store sell the boards in order to maximize profit? So now I get to this idea of profit. I'm going to make a $sign to stand for the amount of money made in all of the sales of N boards at a particular price. There's also $25 is the cost to make each board. So the profit is going to be the difference between how much sales are made by selling boards and the cost it takes to produce the number of boards that were sold. In other words, profit is going to be the price of each board times the number of boards sold minus $25 times the number of boards sold. I've finished the reading and I've produced as much as I initially could out of the reading. Very often in these problems, it takes a second or third or fourth time in order to understand the situation and find relationships or variables that you hadn't previously. But we'll see if this is enough to maximize profit. In this case, the $sign was the symbol given to the idea of profit. The profit equation is P times N minus 25N. If I'm going to maximize profit, then I need an equation for the profit in terms of a single variable. I'm going to use the first derivative test to find a maximum if that equation has one. But my profit equation is in terms of two variables. I have expressions made for those two variables. If I substitute them in, I can create a version of the profit equation that's a little changed. Instead of P price, I'm going to substitute 40 plus I. Instead of N, I'm going to substitute 50 minus 3I. Minus 25 times substituting N again, 50 minus 3I. Here I have an equation with one variable I. I got a little bit lucky that my setup allowed me to substitute and find an equation that will maximize for the variable that I wish to maximize in terms of another variable. I'm going to use the first derivative test. After distributing and combining like terms, I get negative 3 I squared plus 5I plus 750. I did that because taking the first derivative of my profit equation then becomes negative 6x plus 5. Simple derivative to take using the power rule. If I set the first derivative equal to 0, then I'm looking for zero slope tangent lines, which will be critical points that can be tested to be maximums or minimums or inflection points. I'm looking and hoping for a maximum. Solving for not x is a contextual problem which my variable was I. I stands for price increases. I get critical points I at 5, 6, or approximately 0.833. Price increases are going to be dollar amounts, so this 0.833 is approximately 83 cents. What I found is a zero derivative, which is a critical point. I still have to show, given a sign line, that the derivative of my profit equation before this critical point, I'm going to choose 0. In this case, if I put 0 into the derivative, I get 0 plus 5, which is 5, and a positive derivative before my critical point. And I want to show sometime after 5, 6, or the derivative at 1, which is putting 1 in, and the negative 6 will then have a higher magnitude than the 5, giving me a derivative at 1 of negative 1, which is negative. And I've shown that at the critical point, the derivative has changed sign from positive to negative. It was increasing, reached a maximum, and then decreased afterwards. So this is a maximum. That means that I will have a maximum profit with an increase in price of approximately 83 cents. My price then is equal to 40 plus that price increase. And now I'm going to round to the nearest cent because the context of this number is a money amount. So the price of each board is $40.83. Very important information, but to answer a contextual problem, we want a complete sentence that uses the calculation. In this case, I can say, the greatest profit will be made selling skateboards for $40.83 each. And that is the final answer to this contextual optimization problem.